Hello, mathematicians. How are you? I'm Trockers. Okay, we want to solve two problems on numerical methods from Cambridge, June 2022, paper 3, and November 2023, paper 3. Right. So from 2022, paper 3, it was 970933. So it reads, the constant a is such that integral from 1 to a of x squared natural log of x dx equal to 4. Show that a equal to, in parentheses, 35 over 3 natural log of a minus 1 all to the power of a third. Verify by calculation that a lies between 2.4 and 2.8. C, use an iterative formula based on the equation in part A to determine A correct to 2 decimal places. Give the result of each iteration to 4 decimal places. 6A from November 2023, 9709/32. Part A, by sketching a suitable pair of graphs, show that the equation cot of x equal to 2 minus cos of x, here's 1, root in the interval from 0 to pi over 2. Then part B, show by calculation that this root lies between 0.6 and 0.8. Then part C, use the iterative formula xn plus 1 equal to arctan of 1 all over 2 minus cosine of xn to determine the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. All right. Okay, so this is what we need to do. All right, so the question, we are given that integral, so we are given that the integral, this was number 10, right? Okay, so this was number 10. So on number 10, we are given that integral, okay, sorry. All right, so number 10, we are given that integral from 1 to a of x squared natural log of x dx equal to 4. So on part A, we are supposed to show that, we need to show that a equal to 35 over 3 natural log of a minus 1 to the power of a third. All right. So what we need to do now, we just need, for now, let's deal with the left-hand side. Right. So dealing with the left-hand side, we want to integrate from 1 to a x squared natural log of x with respect to x. So now this is integration by parts. So remember, from integration by parts, we use the Light rule. So anything on the left is going to be differentiated and anything to the right is going to be integrated. So L, that's for logarithms, inverse trig, algebra, trig functions, and exponential functions. So as we can see, this is algebra and that's natural, that's a logarithm, right? So this one is what we are going to differentiate because it's on the left, and this one we are going to integrate. Okay, so we are going to let u equal to natural log of x, and if we differentiate, we get 1 over x. So our integral, our dv here is equal to x squared. So if we integrate here, we get x cubed over 3. All right. So we know that using integration by parts, it's going to be integral from 1 to a of x squared natural log of x dx equal to uv. So it's x cubed natural log of x over 3 minus integral of u dv. So minus that, right? So which is equal to x cubed natural log of x over 3 minus integral of x squared over 3 with respect to x, right? So this will simplify to x cubed natural log of x over 3 minus x to the 3 over 9. Then our limits are from 0, are from 1 to a, right? Then here, it's always upper limit minus lower limit. So it's a cubed natural log of a over 3 minus a cubed over 9, right? Subtracting 1 natural log of 1 over 3 minus 1 over 9. So we know that this will simplify to a cubed natural log of a over 3 minus a cubed over 9. Natural log of 1 is 0, so plus 1 over 9, right? But coming back to the question, so if we go back to this question, we were told that this is equal to 4. So now we are going to equate that to 4. So therefore, a cubed natural log of a over 3 minus a cubed over 9 plus 1 over 9 equal to 4. So the goal is to come up with a equal to 35 over 3 natural log of a minus 1 to the power of a third. So as you can see, we have a cubed somewhere. So we need to isolate a cubed first. So let's move the 1 over 9 to that other side. Okay. So if we do that here, we are going to get a cubed natural log of 9. Sorry, it was a cubed natural log of a. I'm sorry, not 9. So a cubed. This is natural log of a, not that one. Okay, so it's a cubed. Here it's natural log of a. So natural log of a over 3 minus a cubed over 9 equal to 4 minus 1 over 9. So 9 times 4, that's 36 minus 1 is 35, right? So it's going to be a cubed natural log of a over 3 minus a cubed over 9 equal to 35 over 9, right? So if we go back to the question there, we now have a 35 and so forth. So what we are going to do is we can multiply everything by 9, right? So if you multiply everything by 9, you're going to multiply by 9 here, you're going to multiply by 9, and we are going to multiply by 9, right? Such that we remain with 3a cubed natural log of a minus a cubed equal to 35, right? So now we can take out a cubed and remain 3 natural log of a minus 1 equal to 35. So the a cubed equal to 35 over 3 natural log of a minus 1. Then now we can cube root on both sides. So therefore, a equal to 35 over 3 natural log of a minus 1 to the power of a third. So this is exactly what we want to show, right? So remember, I said that's the desired outcome here, and this is exactly what we have, right? Okay, so we are done with the first part. Now let's move on to the second part. So the second part of the question, we now need to verify that we need to verify by calculation that a lies between 2.4 and 2.8. So we're going to use the intermediate value theorem, right? So here we know that f of a equal to 35 over 3 natural log of a minus 1, right, to the power of a third minus a. So we are going to calculate f of 2.4, then we calculate f of 2.8, right? So if you plug in 2.4 and 2.8 there, let's see what we get. Okay, so if we calculate that, we are going to get 35 over 3 natural log of 2.4, right, minus 1, okay, to the power of, to the power of a third, right? So here it's going to be to the power of a third, right? So that one to the power of a third, 1 over 3, right? Okay, so with the first one, I'm getting 2.781503,901, which is greater than 0. All right, let's try out that one. Okay, so if I say 35 divided by 3 natural log of 2.8, right, minus 1, right, to the power of a third. Okay, I forgot something on the first one. Okay, I'll go back and fix. Then minus 2.8, right? So this one is negative 0.2411 0.1706, which is less than 0. Okay, so on the first one, we need to fix something. I forgot to subtract by. So let me, okay. All right, so here I forgot to subtract 2.4. So when I say 2.78150901, okay, 2.781503,901, subtracting 2.4 because it's minus a there, right? Okay, I'm getting 0. All right, so it's going to be 0.381503,901, which is greater than 0. So since there is a change of sign, therefore there is a root between 2.4 and 2.8. Okay, so I just want to explain a little bit here. So what happened is that, right, so I have these two zeros, 2.4 and 2.8, right? So when we plug in at 2.4 in our function, we got 0.3 something, which is above here. Then when we plug in the 2.8, we got a negative, which is below there. So somewhere, somehow, we have a solution. The graph passes through the x-axis, so we have a solution in between. So that's why we make this argument that as long as there's a change of sign between the two zeros, or the two zeros here, it means there is a root between those two values, because the graph will pass through the x-axis, right? Okay, so now we have proven this. We are moving on to part C. So part C, it's saying now, okay, so on part C, they are now saying use an iterative formula based on the equation in part A. So the equation, we are now saying an plus 1 equal to 35, right, over 3 natural log of an minus 1 to the power of a third. Remember, it's between 2.4 to 2.8. So normally I take the value in between, right? If I divide that by 2, so I'm going to use 2.6. So I'm going to use my first approximation as 2.6, but you can pick any value between that range, right? So here we can say my A0 equal to 2.6. So to get A1, I'm going to say it's A0 plus 1, which is equal to 35 over 3 natural log of A0 minus 1 to the power of a third, which is equal to 35 over 3 natural log of 2.6 minus 1 to the power of a third. So what I normally do, guys, we need to work smart, not hard. So you input that 2.6 in the calculator here. So you just say 2.6, then you press enter. So it's now stored, right? So what you are going to do is to just say, you are going to say it's 35 divided by 3 natural log. So instead of entering 2.6, just go and enter answer, right? Then from there you subtract 1, then it's to the power of a third, right? So now it's going to use the answer that is stored. So you press the equal sign once, and now I'm going to write 2 point, so I have 2.656709204. Remember, they said each solution should be rounded to 4 decimal places. So now A2, we know that it's now A1 plus 1. So you don't need to redo this because we now know, right? And also the calculator has stored the previous solution. So just press the equal sign once. So it's now 2.62668,958, which is equal to 2.6267, right? A3, so A3 equal to 2.642329,876, which is 2.6423. Remember, this is to 4 decimal places. Here is to 4 decimal places. Everything is to 4 decimal places. Right, so now A4, it's gonna be 2.63411, right? 4112753. Okay, A5, it's 2.6. So here it's 2.6341 to 4 decimal places. Here is 2.6. 38411,027, which is 2.6384 to 4 decimal places. Remember, we want our solution to 2 decimal places. So this is 2.64, 2.64, 2.63, 2.64. Okay, let's see A6. It's 2.636157,488. Okay, so I think we are done here, right? So to 4 decimal places, it's okay, but to 2 decimal places, this is 2.64, 2.64. So therefore, the root is 2.64 to 2 decimal places. And as you can see, it is within that range from what? From 2.4, between 2.4 and 2.8. Right. So guys, we are done with the June 2022 970933 question. Now we are moving on to October, November 2023, and we want to do the 970932 question, which was number 6, right? So let's, okay, I no longer need this for now. So if we come back to the question here, it was this question where we need to make some sketch graphs, right? Okay, so here the question is saying, by sketching a suitable pair of graphs, so we want to sketch the graph for cot of x, cotangent x, and 2 minus cos x. And we need to show that within this range from 0 to x less or equal to pi over 2. Right. So when we are graphing this, guys, we need to bear in mind that, okay, let's start with the graph for cot. All right, so 0, I'm going to stop here on pi over 2, pi, and so forth. So let's just stop there. Right. Cot is the same as saying cosine over sine of x. So we need to go everywhere the denominator is 0, right? So sine 0 is 0. So we are going to put an asymptote here, and that is why even 0 is restricted there. Then sine 180 is 0, so another asymptote is on 180. but we know that sine 0 is sine 0 it's 0, sine 0 is 0, sine 90 is 1, right? So it means for our graph, it's going to be sine 90 is 1, but cos 90 is 0. So this over that, it means the graph is going to have a 0 here, so it will intersect this point. Therefore, for cot, our graph looks like this, right? Looks like that, right? So that's the part for cot x. Now let's see the graph for 2 minus cos x. We know that the graph for cos, remember, is just from 0 to pi over 2, just from 0 to pi over 2, right? Just from 0 to pi over 2 here. And for cos, the maximum is 1, the minimum is minus 1, right? Okay, so graph, we've got 1, we've got negative 1. So cos 0 is there, right? So our graph is like that, between this range from 0 to pi over 2, right? Then negative, it means we are reflecting over the x-axis. So now when we're reflecting over the x-axis, it means we have our negative 1 here, then we have our 1. So the graph will be like that, right? So this is the graph, the portion of the graph that we have. Now, if we shift that graph 2 units up, because it's going to plus 2, so it means whatever was happening at minus 1 plus 2 is going to take place at 1, right? So everything that was happening at minus 1 is now taking place at what? At 1 here, right? Then everything that was taking place at 0 will not take place at 2, right? So everything that was taking place here will now take place at 2, right? So I have my 2 here. So the graph will be like that, in that range, right? So this is now 2 minus cosine of x. And as you can see, there's only one point of intersection, right? Since there is only one point of intersection, therefore the question we wanted to show that there's only so therefore cot x minus 2 equal to 2 minus cos x has one root in the interval 0 less than x less or equal to pi over 2. This was the argument here, right? Then we need to show by calculation that the root lies between 0.6 and 0.8. So we are using the intermediate value theorem. But now, since we are dealing with trig functions, you need to change your the calculator mode to radians, right? All right. So this is part B, right? So our function here, our function of x is gonna be cot. If you want, you can say 1 over tan, right? So cot, you can just say 1 over tan x, right? Plus cos x minus 2. Remember, it was cot x equal to 2 minus cos x. So if I move the cosine here, it becomes positive. If I move the 2, it becomes negative, right? So now we want to evaluate f of 0.6 and f of 0.8. So we are going to plug in there, right? So make sure your calculator is in radians. So it's 1 over tan 0.6, right? Then plus cos 0.6 minus 2, right? I'm getting 0.28703156, which is greater than 0. Then I'm going to use 0.8, so it's 1 over tan 0.8, right? Plus cosine 0.8, then subtracting 2, I'm having negative 0 I get negative 0.33207869, which is less than 0. And again, since there is a change of sign, therefore the root lies between 0.6 and 0.8. Right. So now we are given the iterative formula to use, right? So we are using this iterative formula here. So on part C, we are using xn plus 1 equal to arctan of 1 over 2 minus cosine of xn, right? So again, between 0.6 and 0.8, the midpoint is 0.7. So I can use x naught equal to 0.7, or you can pick any value between 0.6 and 0.8, right? So x1 equal to x0 plus 1, which is equal to arctan of 1 over 2 minus cosine of x0, right? Which is equal to arctan of 1 minus 2, or 1 over 2 minus cosine of 0.7, right? So here, we're going to do the same thing. I'm going to plug in 0.7. So once I plug in 0.7, so I'm going to say arctan of 1 divided by 2 minus cosine. Instead of plugging in 0.7, I'm going to plug in answer. So I just press answer here. All right, then I'll close this. What am I getting? All right, I'm getting 0.68. So I have 0.6805751901. And again, I'm supposed to write this to 4 decimal places, right? So that's my x1. Then x2, we know that it's x1 plus 1. So if we press these ones, it's going to be 0.6855022675, which is equal to 0.685524 decimal places. Then x3 equal to 0.68425788837, which is equal to 0.6842 to 4 decimal places, right? Then x5, so x4 is 0.684572518, which is equal to 0.6846 to 4 decimal places. But remember, guys, we want our answer to 2 decimal places. So this was 0.68, 0.684. So therefore, the root is 0.68 to 2 decimal places, right? Then we are done here, right? So guys, just to summarize this, you need to know how to sketch the graphs. You also need to know how to switch from radians to degrees. So when you're dealing with trigonometric functions, make sure you are using radians. With that being said, guys, I'm signing out. Take care, and I'll see you in the next segment.